Hello guys. So today we are here to solve this sum root to leaf numbers. This is today's lead code challenge, and in this problem we are given the root of a binary tree containing digits only from 0 to 9 only. So the content of a node are digits, and those digits are restricted to have value only from 0 to 9. So it can be 0, 1 up till 9. Okay, and we need to take the root to leaf path. So see this 1 2 and then 1 3, so 12 plus 3 is 25. So we have to sum this path. Okay, so see, this content of this root node is 1, the content of this left child node is 2, and it has got two leaf nodes, and these are all null. This 3 has got two leaf, two, this 3 itself is a leaf node, and the leaf node has two, we can think that the left child of the leaf is not, it's obvious, leaves, it contains no children. So, and that's how it is mentioned in the problem statement also, that a leaf node is a node with no children. So we have to go till the leaf node only. Okay, if we go past this, then it could be that the node is having value, null node, this null node is a problem for us, because that could be having a value. Let's say we can assume that the null node value is having the value 0. So if we try to accommodate that thing, so once we try to code this problem, things will be clear to us. So without so first of all, what we'll do, that we'll start from the root node, go down the left path, and once we go down the left path, we'll get the value 12, and this sum will be added with the value which we get from the value on the right side. The right path, the value is 13, and 12 plus 13 is 25. So how are we going to do this? So to do this, since we have to return the sum, it makes sense that we declare a variable called sum. Okay, if by chance that the root is null, okay, if it is null, then no issues, will directly return the sum. Otherwise, what we'll do, we will go down the path. How are we going to go down the path? So while going down the path, what all information do we need to pass? We need to pass the information of the current root value, so that the lower down the path, the, let's say we go down the left node, left side, we go down the node having value 2. So once we reach the node value with the value 2, once we go over here at this node, we have to know that what was the value in the previous node. To do that, we need to pass this value in the number. So what we'll do, that we'll call this some numbers, and here we'll pass root, and we'll pass sum. Okay, so see, we are same function name, but we are adding one more parameter to this. So we have to define, okay, we have to define this some numbers. Okay, and in this we'll pass this tree node, which is the root, and sum. Now, what will be the first check for us? So see, the first check is going to be for us is if root is equal to null. Why we need to check this? See, already we have checked if root is equal to null. So obviously root, the value which is given to us in the problem, is not a null anymore, because once we have reached the line number 20, in the previous line we have checked, if it is null, then we are returning. So only way we could have reached line number 20 is when the given root to the problem, the input root to the problem is not null. So why again at line number 24 we are again checking if root is equal to null? This check is done at line number 24 in order to make sure that once we go down a leaf, suppose uh, we are at node 2, and we go down on the left side. So on the left side, the null node is there, and what should we return in that case? In that case, we cannot return this sum. Why? because if we return this sum, then what about the other node? That also is going to return, the sum. So, but the content of that is 0. If you are going to return the sum, that sum is going to, accumulate. And that accumulation of two sums when there's actually no value is going to disturb the balance of our, problem. So what we are going to do, we'll be returning 0. Directly we return 0. That makes sense also. Now, after this, what we will do, that we will take this sum into 10 plus this, the current root value. And how, since we have already checked on line number 24 if root is equal to null and we are returning 0, so we can be sure that this root is not null at line number 25, and we can access its value. And once we access its value, we can get the sum. Now, the most critical aspect of this problem, here what we need to do. So once we have, suppose we have gone down to this node 2, so 1 and 12 is there. So in the sum, the value is now 1 and 12. Now, since 2 is a leaf node, okay, there is no path beyond 2. If we further descend down, let's say we call some numbers 2 dot left and 2 dot right, this node's left and right, then these values are 0, and because the root is equal to null, because left child of 2 is null and right child of 2 is also null. So obviously we are going to return 0. And once we return 0, it will be kind of the value will be lost. The sum value should be actually 12, but we are returning 0. So in order to avoid that kind of situation, what we need to do, that we need to put a check over here. If root dot left is equal to null and root dot right is equal to null, immediately we return the sum. Okay. Otherwise, what we do, that we take this sum numbers, and then, so this, we are reaching line number 27 only in the case that there is a path, and that path could be either left is not null or the right side of the current root is not null. Root dot right and sum like this, and once we have returned this should solve our problem. So let's run this. Null. Okay, we have to give double L. Perfect. So let me know how you like this solution. Please post your thoughts in the comments. That is really big encouragement to me. Any doubt, if you have, please post it in the comments. And definitely I would like to learn more from all of you. So with this, I'll end this video. Thanks a lot.